Alright, welcome back. So in this video I'm going to talk through coterminal angles and what they mean and how we would find them. So we say that two angles are coterminal if they share a terminal side. So this would mean that their terminal sides align or coincide. So if we look at a circle and we imagine what this might look like, we would have a first angle that has a terminal side, let's say here, but then you could imagine that we could go around one full revolution and then continue and end up back in this same location. So these two angles would be coterminal, even though they're different. So one angle is just this little bit, and the other angle goes a full rotation and then a little bit more. So these are coterminal, they have the same terminal side. This also works if one angle is positive and the other is negative. So let's say we have a negative angle that goes just down, so let's say to here. We could also have an angle that goes around all the way to meet where that one ended. So these would be coterminal because their terminal sides end up in the same location. So because these are always ending in the same spot, we can say that coterminal angles have a difference of some number of revolutions or full rotations. So we're going a full revolution or rotation, 360 degrees or 2 pi, to get to that same spot. So this means that coterminal angles are off or they differ by 360 degrees, which is 2 pi, or they could be multiple rotations. So they could be off by 720 degrees, which is 4 pi, or 1080 degrees, which is 6 pi. So we're going to use this fact that coterminal angles differ by a full revolution to help us when we're trying to find coterminal angles. So for this first example, let's say that we want to find an angle that is coterminal to 405 degrees that's in the interval from 0 to 360 degrees. So we're starting with an angle that's bigger than 360 degrees, and we want to find out which angle is coterminal that's in this smaller interval from 0 to 360 degrees. So the way we're going to do this is to subtract one rotation to get us down to that smaller interval. So I'm going to subtract 360 degrees from my 405 degrees, and I'm getting 45 degrees. So we've taken away one full rotation to get us into the right interval, and so we can now say that 405 degrees is coterminal to 45 degrees. And if we draw it, we could think about going the full revolution, the 360 degrees, and then 45 more for that 405 degrees. And this would mean that it is coterminal to 45 degrees if we just drew that. So this method of subtracting one rotation to get us into the right interval is going to just help us do this by hand rather than trying to visualize it on a graph. It's not always subtracting one rotation. In some cases you might need to add one rotation, or you might need to do more than one. So let's go through some examples where those other cases happen. Let's say we want to find an angle that is coterminal to 1070 degrees that's in the interval from 0 degrees to 360 degrees. So we're starting with an angle that is very large in comparison to our 0 to 360 degrees interval. And so we're going to need to subtract off one revolution at a time until we get back to the right interval. So first I'm going to subtract one revolution, minus 360 degrees, and I'm getting an angle of 710 degrees. So this new angle, which is coterminal to the one I started with, is still outside my interval. It's still too big. So I need to repeat this process. I'm going to subtract another revolution. So I'm going to subtract 360 degrees, and when I do this, I get 350 degrees. And that 350 degrees is small enough, it's in my interval that I'm looking for. So the angle 1070 was just really big. We had to subtract off two revolutions to get us down to 350 degrees. And so now we could say that 350 degrees is coterminal to 1070 degrees. And we can imagine this on the graph too. 1070 degrees goes around twice and then almost 3 full times, whereas 350 degrees is just almost one full revolution. Okay, so we've done 2 examples with degrees. Let's do 2 more examples, but this time with radians. Let's say that we want to find an angle that is coterminal to 8 pi over 3 in the interval from 0 to 2 pi. So we're starting with 8 pi over 3, and we need to get a coterminal angle. So a good thing to work on and practice when you're doing things with radians is to think of what 2 pi is in terms of my fraction. So my fraction has a denominator of 3, so 6 pi over 3 is 2 pi. 6 pi over 3 is 2 pi. So we're bigger than that. We're 8 pi over 3. So we have something outside of the interval we're looking for. We have a big angle. So we're going to need to subtract 2 pi to get us down to the right interval. So I have an angle that's too big. I'm going to subtract 2 pi. 2 pi is 6 pi over 3. So I have 8 pi over 3 minus 6 pi over 3, and that's giving me 2 pi over 3. And now this answer is in my correct interval. So we would say that 2 pi over 3 is coterminal to 8 pi over 3. Now, if for any reason you are really struggling with radians, you can always convert to degrees and do the math in degrees and then put it back into radians. I just personally think that this is a good opportunity to work on your fractions and some reasoning around the numbers and like how big they are, how small they are, to get us just used to the radians. But if you're ever stuck and you're not sure, you could always try to convert it to degrees to help you out. Okay, so let's try this again. Let's find an angle that is coterminal to negative 7 pi over 9. So we have a negative angle now. And we're looking in the interval from 0 to 2 pi. So here with a negative angle, we need to get it positive. We need to get a positive angle that's in the interval from 0 to 2 pi. So here we can't subtract a revolution. We need to add a revolution. So we're going to add 2 pi to get us back into the right interval. So we're going to add 2 pi one revolution, and to do this, because we have fractions, I'm going to write 2 as 18 over 9. So I'm actually adding 18 over 9 pi. I choose that because they have common denominators. And so I do negative 7 pi plus 18 pi, and I'm getting 11 pi, and it's over 9, adding those two fractions. Okay, so now I have 11 pi over 9, and I'm pretty confident that's my final answer. The way we can just check or think about it really quickly is 11 pi over 9 is a little bit more than 1 pi. 1 pi would be 9 pi over 9. 9 over 9 is 1. So we know that we're just a little bit over 1 pi, so we're in this interval from 0 to 2 pi that we're looking for. It's not like we're somehow outside that interval. We're not bigger than 18 over 9, which would be 2. So we would say that negative 7 pi over 9 is coterminal to 11 pi over 9. Alright, so that's a little introduction about coterminal angles, and we went through 4 examples of how to find coterminal angles in a given interval. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.